Hello everyone! So I'm going to be talking about some of the basics of logging and best practices. And these are based on the 10 Commandments of Logging by Bryce Figueroa or Master Zen. So to get started, first, he recommends using a standard library because otherwise you would have to be using printf statements all throughout your code, and cleaning that up would be a waste of time. And also, printf statements tend to have a sizable impact on your performance. So it's better to use a standard library like log4j or JCL or any of these other standard libraries to do your logging and also be able to turn it off when you want to. He also says you want to log at the proper level. So the level of logging is pretty important. There's always these typical levels, and these are just some suggested guidelines by Apache JCL. So at the trace level, starting at the bottom, you have the most detailed information, and you should expect these to be written to logs only. This type of logging is usually not what you want to see in production because it's the most detailed information, and so you should only use it during development to track your bugs and don't commit it to your VCS. The next level is debug, and this is also detailed information but focused on the flow through the system. You should also expect these to be written to logs only. But this is typically most used during debugging, which is why it's called debug, and Master Zen advocates trimming down the number of debug statements before entering the production stage, so just leave the most meaningful entries that you have left in your code. And then the next level is info, and these focus on interesting runtime events like startup and shutdown. And you want these to be on your console so you can see them, but also keep them to a minimum. Master Zen likes to use these for user-driven or system-specific events. So like regularly scheduled operations. Yeah. And then warn level is for your almost errors. So these are runtime situations that are undesirable or unexpected, but they're not necessarily wrong. So, for example, it could be when your memory cache is near capacity, or if a database call took more time than a predefined time. So this alerts you to a possible issue that might happen soon and lets you troubleshoot so you know how your system is behaving before the failure actually happens. And next is error. So these are your actual errors, and you want these to be immediately visible so you can see when something bad happens. And you can also see the conditions that happens when these errors happen, so you can hopefully fix them. And then lastly, there's fatal, and these are severe errors that cause premature termination. So you also want these to be immediately visible on your console. And you should ideally use these very scarcely because that shouldn't happen a lot in your real program, but it's there for you if you need it. And within log4j, there's also off and all levels. Off is the highest possible rank, and it turns off all logging, and all is the lowest, and it will allow all of these to be shown and logged. So yeah, those are your log levels. And next, Master Zen says that you should write meaningful logs, which makes sense. You should give context because most of the time in an emergency situation, you might not have anything else but your log file. So you want to be able to understand what happened just based on the log that you wrote. And then also, you don't want to write logs that depend on previous messages, so make sure that they are independent. And you should write in English because that's the most common language, and the characters themselves are most easily or most commonly written. And machine parsable formats. So that is talking about JSON, for example, or key value pairs. So there are various ideas out there about how you should log, but one good idea is you have a hybrid mix. So for each event, you log something that a human could read, but you also log the more detailed information in a machine parsable format so that you can more quickly and easily analyze your logs and understand what is happening. And then you have to log not too little and not too much, because logging too little will not help you in debugging or fixing errors in the future, or not give you enough information. And logging too much could affect your performance or make your code pretty much unreadable. So the tip that MasterZen gives is log as much as possible during development, and then review it for production and troubleshooting, and keep it to a minimum then. And then you want to consider your reader. So depending on who you're logging for, they have different needs, and so you should only log what they want to see. And finally, logging is more than troubleshooting, and this kind of goes back to the previous point of logging for your audience. So for auditing, that could be logging events that matter to management or legal. So these are usually user events, like who logged in or what did they change in your program. There's also profiling, which is about profiling sections of your program for performance metrics. And you could also log for statistics and compute some interesting statistics about your program or about your users. So logging is more than troubleshooting. And those are the basic best practices for logging as defined by MasterZen and a few other people. Now let's jump into the code part. So we have a basic project where there is a user interface that asks the user to add a record, delete a record, print a list, or search for a record. And there is a database that collects records. And the record is basically just a person with a name, age, and ID. So first we want to install Log4j for logging. This project was set up using Maven, and so Log4j has a dependency that you can just add to your POM XML file here, but we can also add it using in VS Code, the Maven dependencies under Java projects here. And the name of the package is Log4j core, and you want to look for the Apache logging Log4j core. Now, there is also another dependency that has to be added, the Log4j API, which the Log4j core just adds automatically because it probably depends on it. So we don't need to add it here in our POM XML file, but it would probably be good practice too anyway. But now that we have added it, we can start logging. We'll start logging in our user interface class, and normally you want to have a logger for each class so that you can filter the output by each class. And you also want to declare your logger as private static final. It's private because you don't want anyone else accessing your logger. Static is debatable. Some people want to use it so that they can save on memory, so you don't have one logger per instance of your class. but other people have other reasons for not using static, and final because you're not going to be changing your logger. In Log4j, it is a logger object, and name it whatever you want, and log manager is what creates your logger. Get logger, and then inside here you want to use your class name, and that is typically how you name your loggers. And then you have to import from Apache Log4j. And now you have a logger. I also want to log in my database class, so I will quickly write a logger here too. So now we have to configure how we're going to log, and usually, although you can log within your code, the more preferred method is to log in a configuration using a configuration file, because then you can keep all your settings in a single location. So first, you have to figure out where to put that file, and the right place to put it is in your class path in a resources folder. So here we're going to create a new folder within main and call it resources, and then within this folder you can put your log4j XML file or properties file, or there are so many other options that you can look up on the log4j documentation website, but for now we're just going to use XML. And so they also have a basic sample starter code here. So you have to define the three main parts of a logger. You have loggers, and then you also have this root logger, and here we're going to set it as debug, but this is like your parent logger in the hierarchy for log4j. So if you define others, then those are more specific and they will pertain to those classes, for example, which is what we're going to do, but the root logger will be the logger for any other code. And then the appenders, these are the objects that forward logs from loggers to an output destination. So this is where you specify if you want it to go to a file or to the console. And within your appenders, you have layouts which specify the specific format of the log messages. For us, we would like to append to both the file and to the console. So here, this would be appending to the console, and we named it stdout. And we also told it this is the format layout that we would like. So it gives the time and what class you're in, and then the logger name and any messages. And here is the file that we would like to append to. So we decide to name it testlog.log, and it'll just be in our class path. And this is, we kept the same layout for the file. And now for our loggers, we would like both to log in the database class and in the UI. So here's one logger for the database class, and for this one we're just going to write to the file, and for the UI we will write to both the console and the file. And a key word here is additivity. So because your root logger is the parent to both of these two child loggers, any logging events that come to the appenders will be logged to the console twice. And so to avoid that, you want to not add it to both loggers, so that you want to set these to false. If you're curious about what this top status means, that specifies the level of internal log4j events that will be logged to the console. So those are really specific to how your loggers are being troubleshooted. What's more important for us is this root level down here, and this is where we can specify what level that we want to log at. And this is also where we can enable or disable logging. So for now, it is set at debug so that we log all events from debug higher. And then within our loggers, we have specified the level to be trace so that we get the most detailed logs from each of these two loggers that are in our classes. The default running level that you want to log at kind of varies depending on your need. So eventually, if you want to switch off most of your logs, you can do that and just change it to a higher level like warn or info. But since we're in the development stage and troubleshooting or debugging our code, we want to see all the details. So we want to set it at debug or trace. So now that we've configured our logging, then we can start logging finally. So let's start with our user interface main class. And we're going to start with a logger.info so that we know the main event of having our database established, and then starting UI input. And then after the input method has ended, we can also log the info of exiting main. Now in the input method, once we scan in what the user has typed, we might want to see if we're reading it incorrectly. So I put a logger.trace user typed, and this gives it some context so I kind of know this is what the user typed. Answer. I chose to log that at the trace level because eventually I don't need to see what the user typed every single time if I know that it's correct one time. So eventually I will probably turn that off or delete this line. But for now it's at the trace level. And then within each of these cases, I might want to test whether the program is comparing the user's answer correctly to each choice. So within here, I could also put debug and see if it matches the option that we want it to. And I'll do that for the other cases too. And at the very end, outside of this while loop, we might want to know that the user has quit. So I'm going to put that at the debug level to show that the while loop flow of the code has ended and the user has quit. And so similarly for the rest of these methods, I could go through and use the same pattern of using the debug level to show changes or events in the flow of the code, and using trace to show or log more detailed information, like what the user has input or specific variable values. But here what's interesting is there is possibly an exception if the user does not put an integer for age, and so the scanner can't read in the next int, even though that's what it's expecting. And so here we could use the logger error level to show that there's an exception and you want to retry. So I can go through and continue that pattern of debug, trace, or info or error for each of these methods in the UI, and I also did that for the database. And so now we can just run the main and see what our logging does, and to see if we have any errors. So let's start with an add record and the name John. But first let's just do one that works, that a user that gives the program something that it expects. So we see that it's added the record ID 0 with the new age correctly and the name John. We can also see that in our file here, and initially the database size was 0, and we can see here is where our program started. But let's continue our testing. Let's try to add a record that isn't correct. So let's give it John. And oh no, we have an exception because it was expecting an int, but instead we gave it a string. So we have to retry to add again. And it works fine, and so we continue. Let's try deleting name. But there is no record with that name in our database right now, so that failed. And we see that, and we can continue. And now we see that we did successfully delete record 0. Let's add another record just so we have more people to work with. And the ID is now 2. Currently, we can only filter by age because that is what has been written. Let's filter by but there are no records by the age of 20. But here we see Penelope is 19, so that worked. And now let's search for a record, and we'll search by Lionel, but we see there is no record with that name. That is the program telling us, but also here our log is telling us that it failed to find a record with that name. And correctly, John is no longer in the database, so there's no record with him either. And Kelly is found successfully. So now let's quit. And we see that the program has exited. We can also look at our file to see all the sizes of the database as we did those changes. And also some more interesting facts with more detailed information. And now let's say that we want to change the level of logging so that we want to disable all logging. We can do that by going to our configuration file and changing the level to off. And within both of these two classes, the logger is at the level off. So even though this root logger is still at debug, it won't matter because these are the loggers that are specific to that class. But if we did want to turn off all logging in every single class, we would also put that as off. So now going back to our UI, we can run it. And we see that there is no logging. There's also no more logging at the end of this file, which it would just append onto the same file if it were logging. So just some last advice on logging, the basics of logging before I end this section of the video. So here is an example logging style that someone posted on Stack Overflow. And each of these events, log events, makes sense. You would want to know these. But seeing this whole list, you can kind of expect that your code might get cluttered pretty easily. So Jeff Atwood talks about this problem with logging on his Coding Horror blog. And he says, resist the tendency to log everything. His advice is to start small and simple and log only the most obvious and critical errors that you might expect or not expect. And also just add more logging as demonstrated by specific verifiable needs. So that way you cut your logging to a minimum and focus on the most important parts, which are your errors. Because at the end of the day, logging could still have an impact on the performance of your code. So every logging line that we wrote only took in a string message as a parameter, but you could also pass in other parameters. For example, you could call a method, and if that method is computationally intensive, then the way that the logging works is it will first resolve the parameters and then check if it needs to log the message or the result. And so the best way to handle that is with the guard methods, so that you check if you need to log or resolve parameters first before you actually run that line of code. And more on that in the next section.
One thing programmers are worried about whenever introducing logging is if it will slow down and add overhead. So to test this out, I created 10,000 records as a data set, and I'm going to test it with logging and without logging to see if it affects the time. So as you can see here, I add the 10,000 records and then later remove them in succession so there is overlap. As you can see in this case, there is logging, adding that I added the record and that I removed the record, as well as that the data set was created and the data set was added and then that was removed. I do not time the creation of the data set. As you can see here, the timing starts afterwards. And then also I have timing for whenever we do not have logging. So testing this, we see an average time without logging of 3.3 repeating and with logging of 11, the max of 21 and a min of 7, and without logging a max of 13 and a min of 1. And I'll run this multiple times so we can get a better estimate. As you can see this time, it was even greater at 19.86 and down here at 7.6. One more time to get a better estimate. Lastly, we have 15.267 and we have 4.53. As you can see throughout these examples, the without logging is much better, even with this small sample. Now testing with it running through 50 times to get a better average. We see an average time of 2.72 without logging and an average time of 6.4 with logging. Again, it is more than double. In Java, there is a way to cut down on this overhead by using code guards. These code guards are an if statement that go before the logging that you wish to have that is simply asking if the debugging is enabled. This will cut down on the overhead and therefore make your code a little bit more efficient whenever the logger is turned off. As you can see, whenever I run this, on average, the times will be better. So beforehand, it was usually above 6, if not up to 15, and now the average is 3.38. I'll run it again just to double check that. And once again, we have another 3.82. As you can see, these code guards cut down on this overhead, which allow you to have faster runtimes whenever the debugging or logger is turned off.
All right, so today we're going to be talking about JUnit unit testing in VS Code. So basically, since we already know what unit testing is, what I'm going to do is kind of walk you through some example code, kind of how to initialize a unit test, how to interact with it on VS Studio. So as you can see right here, we have two classes, a record and a database. So let's just take a look at this record class for now. So we just have really simple methods. So the constructor, where we initialize an age, name, and an ID, and then we just have a bunch of getters and setters for those different methods. So I already implemented a record test class. So this is how you would implement something in JUnit. So in order to first use JUnit, you need to import the org.junit.test, and then also whatever assertion that you're going to use. So the way that a unit test works, at least with JUnit, is you create a method where you know the answer to that method. So you assert that the output of that method is going to be what you know that it should be. So if that assertion fails, then you know that your test failed and that there's something wrong with the method that you perform that unit test on. So the assertions kind of range a vast amount of them. So straight from the API of JUnit, we have assert array equals, assert equals, assert false, assert not null, assert not same, assert null, assert true. There are a lot of different assertions that you can do. Today we're going to be focusing primarily just on assert equals and assert true. So walking through this test class here, we can see that as we go through, the way that VS Code picks up what a unit test is through JUnit is with this @test tag. So when you tag a method using @test, this run test and debug test will pop up that allows you to actually perform the test. So it's standard practice in Java to, when you create a test class, first that class is the name of what you're testing followed by test, and then each method is test undercase, and then the name of the method that you're testing with the first letter in uppercase. So for example, this would be testing the constructor, this would be test record. So right now we're testing the constructor. So we know that the constructor initializes the record to be to have a date of birth, or sorry, to have an age and their name, and then it defaults the ID to -1, just based on the constructor. So when we make a new record here, we're going to create a new record and have the age be 24 and the name be Danny. So we're going to expect the age to be 24 and expect the name to be Danny, because that's what we know that the record should be. And then we also know that the expected ID should be -1, because that's what it's initialized to. So we are going to assert true that record.getAge, assuming this method works correctly, gives back the expected age. They should be the same thing. Same thing for getName and the expected name, and getID and the expected ID. All this is doing is asserting that what we know should be the output of this constructor is the output of the constructor. So by asserting all of these true, if we run this test, then it should be okay. Yep. So we see we get a check mark right here, which means that our test ran successfully. That means that it worked as expected. So following down through to the rest of them, we have test set ID, we have test get ID, which all follow the same basic theme of the last test. So we can see on test ID we use assert equals instead of assert true. So when we set the ID, we know that we're setting the ID to be 1, 2, 3. So since we created a record with the age of 24 and the string Danny, and we set the ID to 123, we know that the record that belongs to Danny, so under the name rec, the age is 24, the name is Danny, and the ID is 123. So we can set our expected ID to 123. So now we're going to assert that our expected ID and the actual ID are the same. So if these two actually are the same, then our set ID method works correctly. So let's run the test. And it works correctly. So same basic format for the rest of them, and we essentially created a test for every method in our record class, and that is what that is a unit test being performed on every method. So in the record class, I created a date of birth function. So we had set date of birth and get date of birth. There's no initialization in the constructor, just for the sake of the video. So let's create a test on set date of birth, assuming that get date of birth works. So we're going to go into record test. And the first thing we're going to want to do is call an @test tag. And then we're going to create a test. So okay, so let's create a new record just to initialize it. We'll have it be the same thing as all the other ones. So new record Okay, so we know that that's going to be a record. The name is going to be Danny, and the age is going to be 24. The ID we know is going to be -1. We know that to be true because we even tested it. So now let's call set date of birth to 6/19/1996. So we know that that's our date of birth. So let's set our expected date of birth to be what we know we just set it to be. So string expected DOB. Okay, so if this function works, or if this method works correctly, then the expected date of birth and the actual date of birth should be the exact same thing. So we can use an assert equals expected date of birth and the actual date of birth, which is that record dot get DOB. And again, this is assuming that the get date of birth method works correctly. So we can run this test, and we can see it works correctly. Now, if it doesn't work correctly, let's say we have an error. We assume, or maybe let's say in our set date of birth, we say we add an L onto it, onto the end of the word, or the name, or sorry, the date of birth. So now let's run this test. We're gonna get a test failed. And here we can have all of the different, the reasoning and logic behind why it failed. So because this is a unit test, we can go in and see exactly where it failed in our method because it's only a little bit of code. Obviously, this was the unit test that we're performing on. We can see why is this here, remove it, and it all should work correctly. So going back to the record test, lastly, we can see that at the top of the record class, we also have a run test, and this runs every single unit test. So it goes through every single one and makes sure that they all run correctly, and it works the exact same way as the individual unit testing does. So we can click run test, and all of the tests passed. So then, and again, this is the Java test report. This only pops up really when you get a negative test, unless you open it up. The default action is to only come up when you get a negative test, but you can also open this up to see that each individual thing passed. But the easy way to check is just to make sure that you get the little check mark. And that is how you perform unit testing in VS Code.
Unlike a unit test, an integration test is used to check to see if the different parts of your program can work in conjunction with each other. So instead of using mocking to test our interface, we're actually going to use the real database alongside the real interface to make sure that all of the code that we've written for them to interact is actually correct. Integration tests are important because mocking can lead you to have a false sense of security that you've really tested your program in a good way. You could have easily missed certain edge cases while writing your mock, and you didn't fully test all of the different fringe cases that your program may have. So you always want to do an integration test to make sure that your program actually does everything that you think it is supposed to do. So I have written a very simple test here for the integration between our user interface and our database. I'm using this input file as what input the interface is going to read. All I'm doing is reading in 3 records into our database and then deleting one of those records. Therefore, this test here, which just checks that the size of the database is 2, should equate to true. So when I run the test, hopefully nothing happens because that means that our tests passed. So obviously, you're going to want to write more extensive integration tests than just what I have here. You would probably, or most certainly, want to make sure that you call all of these database methods via the user interface. That way, you're guaranteeing that all of the code that connects those 2 pieces of software are actually calling the correct method with the correct parameters, and all of the outputs that you get are what you expect. This is how you can actually feel confident that you have connected these 2 separate pieces of software correctly if you test all of the things. I can't show it with this project, but there is an even more complex level of testing called systems testing, where you test the integration of not just 2 pieces of software, but all of the pieces of software that go into a much larger project. It's just as important as integration testing because the more pieces that you put together in a project, the more complex it becomes and the easier it could be for the code to have errors in it that do not have the pieces interacting with each other correctly.
Hello there. Today we'll be discussing mocking, how we get access to it, and what it's good for. So let's get into it. So before we begin anything with mocking, we're going to have to go down to pom.xml, and since we're using Mockito for our mocking, we're going to have to set up a dependency on it, as you can see here. That we are grabbing Mockito core. It should be also noted that JUnit is also required to use Mockito. So if you don't have it by default, you're going to need to get it. One important thing to note is the scope line here, which says test, which means that this dependency isn't used outside of the test folder. As you can see, we have our source, and then we have main, and then we have test. If this said main, then we'd be able to reference Mockito in main only, but in this case, we're only able to reference it from the test and subfolders of test. So, with that out of the way, come over to mock test just to talk about what mocking actually is and what it's used for. So pretty much what a mock is like a fake version of a class, essentially. It reacts to like all the methods, but doesn't contain any of the information from them. They're essentially blank slates. This is useful for when you have a class mapped out, but you don't have the functionality programmed in yet, but somebody else wants to test something that relies on your class that's not done yet. They can mock your class, and then through what Mockito offers us, we are able to simulate some returns, which is good for us. So, how you create a mock. So as you can see here, we have a database interface called DB. Obviously, anything that has the database interface should work here. So when we start it up, we're going to have db equals mockito.mock database.class. What this does is has Mockito generate one of these fake classes for us, and it's pretty simple to use. You just have to type that in and tell what class you're looking to mock, and it It'll just set up everything for you automatically. Very simple. And you can see on this line, there's a test record. This is just something I'm using for tests. You'll see what exactly in just a bit. So obviously when we first generate this mock class, anything that is expected to any method isn't going to do anything if it gets called. It won't crash or anything, it just won't do anything. It's not going to return anything either. So if we want these methods to do something, we're going to have to tell Makito some basic simple stuff what we want to happen. Now obviously we can't have it do actual computations or something complicated, because that would defeat the purpose of a mock, because otherwise we should just program that into the actual class and then we wouldn't need to mock. So as you can see here, we have this when method from Makito. So essentially what this does is you reference our mock object, and this is a method on that mock object with a specific argument passed in. Then using this method we can tell it what it should return in that scenario. So in the case that for our mock, if we call the find method with the parameter Charles, then we will return our test record, which is right here. Right here. And then there's some other fancy stuff like the any parameter, which basically says that what this does is if we run the add method with any record class passed in, then we will always return true. Finally, you'd see that we have done the same thing pretty much, but with the remove. If we remove Charles, then we will also make this test record and return it. What you exactly want to be doing with these mostly depends on what functionality this class you're mocking is. So just a good application of common sense, and generally this isn't too difficult to use. Just to show how it works, we can now run it. So then we have our little prompt about what we do. So based on what we told Makito to do, if we add a record, you can see that the addition will always be successful, because if we scroll down here, whether or not it says it was successful is based off of db.addr. We made that passing any record class in, which add generates one using the information we did down below. Then we return true. So regardless of what we type in, it'll always come out to be true. And just to show how the find works, just to show that it does work, I guess, we type in search record here, and we type in Charles, you can see that we get our little fake information set up. So we can tell that everything seems to be working just fine. So yeah, that's pretty much everything to talk about mocks. It's a very simple system, but can be very helpful, especially if you're working on a team or something, and maybe somebody just hasn't finished something yet, and you need to test your simpler thing that relies on what they have done, and you'd like to get that work done, and this allows you to do it.